I thought I knew there was a sweet spot.
Yeah. You should move back.
That's better.
Something we can always cut out what we don't want to say. As long as you're saying, is it recording?
Yeah. Just recording.
Okay. Dave, I wanted to speak to you about the Math 451 course, and this is the course in classic geometry. Firstly, I thought you would just give us a brief history of how the course developed and how it came to be taught in the way you're teaching it. We can talk about later, but let's first talk about the history of the course and how long the course is going and how you developed the course.
I started the course back in the early 70s, so it's been going about 20 years now. And it was initially offered for the old teacher education program that the math department ran back in the 70s, and that was the purpose of the course at that time. And how it got to run the way it is now, I'm not sure what to say. I've always taught in some version of that way.
But who was it aimed at when you started the course?
Well, initially the idea was for students who were going to become high school teachers, but immediately the course had lots of other people taking it, so it wasn't just for.
And your course is taken 50% graduate students and 50% undergrad, is that?
No, much fewer graduate students.
Oh.
Maybe 20% graduate students. Well, it's just some math ed graduate students mostly, and then math majors and some physics, chemistry, engineering majors.
What I really would want to speak about is what your aims are for the course, and then talk about the strategies that you use to achieve those aims. So, could you tell us what you hope students get out of the course, and what it is you're trying to do in that course?
Well, I want them to get an appreciation of geometry and of experiencing geometry, experiencing experiencing geometry and mathematics in a way that a mathematician does, in terms of grappling with ideas, trying to come to some kind of understanding, to actually just to develop their own ways of seeing these ideas. And I believe that geometry is very is all about mathematics. It's a natural part. It helps us understand things about ourselves, about our world, our universe, and about our experience. And that
Are you speaking about the physical?
Is that geometry, not just the physical experience, mental experience. Because I think that, going back to that earlier question, geometry for training the mind, I think that learning geometry is good for helping one experience something about their mind. But that's different than...
When students come into your course, they come in with one view. When they go out, is it your feeling to go out with a different view of mathematics or geometry?
Well, I think they have lots of different views, and I think they leave with lots of different views too. And in fact, I don't attempt to have the students all have the same view at all. I just try to bring out of them their own ways of looking at mathematics, their own ways of looking at geometry, or looking at their own and understand. And because of that, the reason I know that that's working some is that I learn from the students. So that even though I've been teaching the course for 20 years, every year I learn things from the students, because the students are looking at things in a way that I never thought of before, that I had never seen, never occurred to me before. And so they show me different ways of looking at things, looking at the geometric notions that had never occurred to me, even though I'm an expert and I've been teaching the course for 20 years, but I still get surprised.
How often does it happen?
At least 4 or 5 or more times a semester.
And at these times, the students provide insight to you that you otherwise would not have seen.
Yeah, they're looking at these problems in a way that, you could say, from a vantage point that I hadn't looked at it before, or in a way that I'd never seen before. Or they have a way of putting things together that I never occurred to me.
So you just said that you want students to develop their own ways of seeing things.
Right.
Does that mean that there isn't a right way and a wrong way?
No. There certainly isn't one right way and one wrong. One right way and everything else is wrong. But that doesn't mean that different ways don't have different advantages over other ways. In particular, something that's valuable for me is some way of looking at the problem that I haven't seen before. That makes it a good way, because it shows me something else that I hadn't seen before. And students benefit from seeing different students' ways of looking at it, because they see that there are, for that very reason, that they see other ways other than the way they look at it. And it's not that, and seeing a way that's different than the way that you look at it is good, because it helps stretch your own way of looking at it. So that kind of thing, and I emphasize that. Part of the course is communication. Also, I say this like this. I ask the students to put in writing their own thoughts, their own ways of looking at the problems, their own understandings, and also to communicate it to the class verbally. And I choose students to do things on the board, and both of these are good, not necessarily easy exercises, but student needs to figure out convincing ways of presenting what it is that they've seen, and presenting it to the class. The class sees different ways of looking at it, and what's even best is when it happens that there appear to be even conflicting ways of looking at it, so that there appears to be things that are at odds to each other, that are contradictory to each other, and this usually allows for a lot of creative understanding.
Would you regard your course as being non-traditional?
I guess it depends on just what you mean by traditional. But,
do you think it deviates from the normative way in which mathematics is taught?
Yes. Yes, it certainly does, in that I'm not presenting a fixed body of techniques or facts or theorems for the students to learn, but I'm more throwing out ideas and situations for them to grapple with, for them to experience and to come to their own understanding and their own ways of looking at it.
So would you regard your course as an informal approach to teaching mathematics?
Well, I don't like the word informal, but maybe non-formal is better. It's certainly not formal, and in fact that's an important part of the course, and that in particular we don't have formal definitions of things. In fact, I don't believe that a formal definition can capture the notion of, for instance, a straight line or the notion of an angle. That I don't believe that these basic notions can be captured by definition, and so that. But we spent a lot of time talking about what the meaning of a straight line is, what it means to say that something is straight, and the meaning of an angle. But it never can get finally settled, and from a formal point of view, notion talks about straight lines and so on end up being circular. But that doesn't matter. I mean, one's meaning and feeling about and knowledge about straight lines deepened.
You seem to put a lot of emphasis on the notion of meaning in mathematics. I mean, is that really possible to see meaning in mathematics?
I don't think it's truly mathematics without meaning. So that I mean, one can learn mechanical techniques to solve certain problems and do it without any meaning, but I wouldn't consider that mathematics. I mean, that's some kind of rote mechanics that you can teach a computer to do.
School mathematics. Would you regard school mathematics as being an example of teaching mathematics for meaning?
It can be. It can be taught with meaning. Sometimes is, and often is not.
So you're saying it's not got to do with the content thing that you're teaching,
right?
But with the way you approach it. Is that what you're saying?
Yeah, as I said, I believe that mathematics is a natural part of human experience, and that if it gets taught in that way, then it can come out. And if it gets taught as formal rules to be rotely learned, then it's very difficult.
Don't maybe.
and then, but then I'm not sure where to factor that. So where factoring would come in that case. But yeah, I mean, there are places like the trajectory of a stone being thrown, which is where the equation is erratic, and then when one wants to end very question that, instead think in terms of ways of solving that quadratic or finding values at different points.
Isn't it true that one first have to learn the rules of the game before you can apply that? Isn't it then valid for a school teacher to teach the rules of factoring a quadratic expression in a decontextualized way so that after a while they be able to apply them?
Well, if it's only done that way, then the student cannot see that the rules are natural. I mean, that there's something natural about the rules, and the rules have meaning, and they come from somewhere, and there's it's part of the natural situation that these rules come out, and this is what needs to be created and to experienced. Not just operating with what we, the so-called sense impression. We actually have constructed an image of a book as a rectangular type of object, and that has something inside. And we may be mistaken what's inside. And this is one of these trick books that somebody out on the inside would be surprised. There is meaning there. I mean, there's meaning in this in straightness. I think there's a universal or objective meaning to straightness, and there are attempts to capture what that is lead to various concepts and various images, and that these concepts and images are things that we construct, and that gets constructed in different ways depending on our experience and our cultural backgrounds, etc. And there's meaning in the notion of circle and triangle and so on. Angle.
Well, how about four-dimensional space?
Yes.
There is meaning in it.
Definitely.
But in which way is that natural?
Oh, because, for instance, going back to the book here, when we're looking at the book, that the kind of perception that we have of this book is very a four-dimensional perception, not a three-dimensional one. We can't, from a purely three-dimensional point of view, we cannot see the whole book. We can only see roughly half of the outside at a time. But if we imagine this book but from a four-dimensional point of view, if we would go into another dimension and look at the book, we would be able to actually see the whole thing, which is what we actually imagine. So the imagination does have something. And I think that part of our experience is experience of other dimensions other than just the three physical
dimensions. Let's talk briefly about some of the things that you use to achieve that aim in your class and the way you teach it. Some of the strategies that you use in teaching that. How do you teach for meaning?
Well, I guess what I do is to take situations in which I have been able to experience meaning. And I'll try to present these situations to the students and hope that they will see meaning also, or experience meaning in grappling with that situation. And it doesn't always work. Sometimes it does, sometimes it doesn't. It works with some students and not with other students. And I think it's something I think it's important is I think it's important to be confused. And I think it's important for students to be confused. That it's being in a confusing situation and trying to make sense out of that confusing situation, trying to put some kind of well, sometimes it's putting some kind of an order or seeing relationships or constructing some kind of connections or whatever it is that that working one's way out of confusion is very educative. I mean, one can learn a lot about what the situation is, and it helps one see what's going on. And if one is looking at something before one understands it, or before one has made sense out of it, or seen the meaning in it, it is confusing. And so that, and it's important not to shield students from that. Because otherwise they can't make their own meaning. They can't see the meaning for themselves.
Let's take one example. Just take the example of straightness. Now, what are the kind of situations that you create for the students so that they could see what straightness means in different situations? I mean, what are the actual things that you would, examples or things that you would use?
Well, I asked them just to think about ways that the notion of straight gets used, and in actual practice, how one would check that something is straight, or how one would construct something that's straight, and how one would know, convince themselves that it is straight, and to think of various ways of doing it, a lot of different ways, and so that's one. And then also what helps a lot is to think about straightness in different contexts. For instance, to imagine a bug crawling on a sphere, and to try to imagine what it is that would feel straight, be straight to that bug. If the bug was imagine it as basically a two-dimensional bug, and the bug's whole universe is the surface of the sphere. And what would be straight? And I'm taking it as a basic presupposition here is that everybody knows what straightness is. I don't think that anybody has to be told what straightness is. That's a part of our that's a natural part of our experience, this notion of straightness. And it's just a question of bringing out various images and concepts that are connected with that notion. And there are lots of different ones, and it never gets totally resolved, and there's some ambiguous cases, and so on and so forth. And that's fine.
So you use models and other physical
Right.
concrete
right? Yeah, so for straightness, I mean, I actually, as students think in terms of, given a ruler, how would you check that it's straight? Actual ruler like this. I mean, we use it as a straight edge, but if we were in doubt as to whether or not it was a straight, how would we tell? And and in dealing with spheres, actually push them to actual models of sphere. I mean, take an orange or a ball. Talk about straight lines on cones and cylinders. Actually take a piece of paper and make it into a cone. And to actually, it helps one experience what's going on. It helps our imagination see what's going on with a cone.
Now, isn't that too concrete for a mathematician?
No. I think mathematics is very concrete. So, mathematics is related to is ways of looking at experience. That's what it is to me. And so that if one is going to look at mathematics, one must look at one's experience. One must have some experience to look at. And so that's part of what's going on. And it's and I think most mathematicians do use some kind of model. Nowadays, one of the advantages of using a computer, one of the ways mathematicians are using computers is for the computer to build or build models or images of models, either graphics models or they can be numerical models. It doesn't really matter. But a lot of what's being done by mathematicians now is making models, or having computers help make models, and then looking at these models to trying to experience what's going on in these models in order to get some insights as to what's going on. And I think that's always been a part of mathematics. That's why a lot of mathematics is grown out of physics, where there are some more concrete models. But even in so-called pure mathematics, pure mathematicians draw pictures. I mean, it's one of the reasons why, in order to understand something, mathematicians like to have another mathematician lecture on it. Give lectures, because the lecturer can help draw some of these pictures or models. And these aren't necessarily physical models. They can be just images in the mind, but they still work in the same way as models. So it's not just physical experience. But that when you're actually talking with another person, another human being, it's easier to convey what these images are, or what it is that's actually being seen, than it is when you're just reading, particularly formal writing, about what's going on. But even in formal writing, the good writing is one where the writer is trying to express, what it is that the writer is seeing.
Well, thank you very much, Dave. I think we should have a continuation of this sometime. But thanks for now. I know you have another class, so thanks.
Appreciation of geometry and of experiencing geometry, experiencing experiencing geometry and mathematics in a way that, or in a way that a mathematician does, in terms of grappling with ideas, trying to come to some kind of understanding, to actually just to develop their own ways of seeing these ideas. And I believe that geometry is a very, all of mathematics, it's a very natural part of human experience. And I try to present it that way. It's a natural part of human experience. In fact, I don't attempt to have the students all have the same view at all. I just try to bring out of them their own ways of looking at mathematics, their own ways of looking at geometry, or looking at their own thinking and understanding about geometry. And because of that, the reason I know that that's working some is that I learn from the students. So that even though I've been teaching the course for 20 years, every year I learn things from the students, because the students are looking at things in a way that I never thought of before. I mean, part of the course is communication. Also, I say this like this. I ask the students to put in writing their own thoughts, their own ways of looking at the problems, their own understandings, and also to communicate it to the class verbally. I choose students to do things on the board, and both of these are good, not necessarily easy exercises, but the student needs to figure out convincing ways of presenting what it is that they see, and presenting it to the class. The class sees different ways of looking at it. And what's even best is when it happens that there appear to be even conflicting ways of looking at it, so that there appears to be things that are at odds to each other, that are contradictory to each other. And this usually allows for a lot of creative understanding. Well, I don't like the word informal, but maybe non-formal is better. It's certainly not formal, and that's an important part of the course, and that in particular we don't have formal definitions of things. In fact, I don't believe that a formal definition can capture the notion of, for instance, a straight line, or the notion of an angle. That I don't believe that these basic notions can be captured by definition. Mathematics is related to is ways of looking at our experience. That's what it is to me. And so that if one is going to look at mathematics, one must look at one's experience.